Ever wondered how your phone understands you when you speak in a different language? Or how AI can translate a conversation in real time across multiple tongues? Today, we're diving into a groundbreaking approach that's pushing the boundaries of multilingual speech recognition. It's called Iterative LoRA Training, and it's changing the game. Let's start with a big picture. Speech recognition systems today are pretty smart, but they struggle when dealing with low-resource languages, those with limited data. Traditional methods often overfit, meaning they memorize training data instead of truly understanding it. That's where this research steps in. The key innovation here is something called LoRA, short for low-rank adaptation. Think of it as a shortcut for fine-tuning massive language models. Instead of adjusting every single parameter in a model, which is like rewriting an entire book, LoRA adds small, targeted changes. It's efficient, but it has a flaw. During training, models can still get stuck in a loop, losing the ability to adapt broadly. So the researchers created an iterative process, 3 stages of training that refine the model step by step. Let's break it down. First, focus training. Here, the model rapidly adapts to the target task, like recognizing speech in a specific language. But instead of overhauling the whole system, it tweaks just a few parameters. It's like learning a new recipe by adjusting a few ingredients, not reinventing the dish. Next, feedback training. Now the model gets more data, like expanding a recipe with new ingredients. But here's the twist: they use pseudo-labels. These are guesses generated by the model itself, refined through a voting system. Imagine multiple chefs tasting a dish and agreeing on the best version. This makes the model more reliable, even when data is scarce. Finally, fixed training. This is the polish phase. The model fine-tunes its adjustments, ensuring it doesn't forget what it learned earlier. It's like proofreading a manuscript, catching errors and smoothing out the flow. What makes this approach special? It's not just about better accuracy, it's about adaptability. By iterating through these stages, the model avoids overfitting and retains flexibility. The team tested this on a major competition, achieving top results in multilingual speech tasks. So why does this matter? Imagine a world where AI can seamlessly switch between languages, understand regional dialects, and even adapt to new ones on the fly. This research is a big step toward that future. Thanks for watching. If you want to explore more about AI, speech tech, or the science behind it, hit that subscribe button. And drop a comment: what language would you love to see AI master next? Ever wondered how speech recognition models get better at understanding different languages? Today, we're diving into a cutting-edge approach that's pushing the boundaries of multilingual AI. Let's break down how researchers refined a model called M2 to achieve remarkable results in speech recognition, without reinventing the wheel. So the big idea here is iterative fine-tuning. Think of it like training a musician. You start with a basic skill, then gradually add layers of complexity. The team behind this study used a method called LoRA, low-rank adaptation, to tweak their model. Instead of overhauling the entire system, they focused on small, strategic adjustments, like adding a few high-quality training sessions to sharpen the model's skills. Here's how it worked. After an initial round of training, they refined the model with broader multilingual data. But here's the clever part: they didn't just throw more data at it. They used a smart strategy to pick the best 2,791 hours of audio, filtering out noise and focusing on high-quality samples. They even used a trick called pseudo-labeling to automatically tag unlabeled audio, like teaching a student to correct their own homework. Then came the 3-stage training process. 1. Focus training. The model learned to zero in on key patterns like common words or accents. 2. Feedback training. It got feedback from its own mistakes, refining its understanding of tricky cases. 3. Fixed training. Finally, it polished its skills with targeted corrections, like fixing grammar errors in a language it wasn't perfect at. But here's where it gets really interesting. They didn't stop at just audio. They boosted the model's knowledge with text and audio augmentation. For low-frequency words, think rare vocabulary or unique phrases. They added third-party text data to teach the model new tricks. For high-frequency words like the or and, they flagged tricky examples where the model struggled and gave it extra practice. For languages with less data, like Thai or Vietnamese, they used a similarity-based audio selection method. Imagine finding a twin for a song by comparing audio fingerprints. They found high-quality samples even without transcriptions. This helped the model handle rare languages without needing tons of labeled data. The results: a massive drop in word error rates WER across 17 languages, from English to Russian to Vietnamese. For example, the model's accuracy on English-American speech jumped from 14.14% to 9.98%. A game changer for real-world applications. But the real win: this approach didn't just improve accuracy, it made the model more adaptable. By balancing data diversity with smart training, the researchers created a system that's both robust and efficient. So what does this mean for you? Better voice assistance, more accurate subtitles, and AI that can finally keep up with your local dialect. It's a glimpse into the future of multilingual AI, one where language barriers fade away, one word at a time. Want to see how this tech stacks up against other models? Check out the full study, and stay tuned for more deep dives into the science behind the AI you use every day. Have you ever wondered how your phone understands your voice, or how subtitles pop up in videos? Behind the scenes, it's all about automatic speech recognition, ASR, a field racing to make machines listen and understand human speech. But here's the catch. Most ASR models are built for languages like English, leaving many Eastern languages like Mandarin, Japanese, or Korean lagging behind. Enter Dolphin, a groundbreaking ASR model designed specifically for these underrepresented languages. But how do you train a model to handle so many different sounds, accents, and dialects? The answer lies in a clever technique called LoRA, short for low-rank adaptation. Think of LoRA as a super efficient way to tweak a giant language model. Instead of retraining the entire model from scratch, which is time-consuming and resource-heavy, LoRA adds small, specialized modules that adjust the model's behavior. It's like giving your car a GPS upgrade without replacing the engine. In this research, scientists took an existing model, M2, and merged it with optimized LoRA parameters. This hybrid approach let them fine-tune M2 to handle Eastern languages with remarkable accuracy. The result? A model that's not just powerful but also adaptable, capable of learning new languages or tasks with minimal data. What makes this work stand out? It builds on a wave of innovations, from QN and Llama to Speech GPT and Whisper, each pushing the boundaries of what ASR can do. By combining these ideas with LoRA's efficiency, the team created a tool that's both scalable and practical for real-world use. So why does this matter? Imagine a world where voice assistants understand your local dialect, or where translators can quickly adapt to rare languages. This research isn't just about better tech, it's about bridging gaps, preserving cultural diversity, and making technology truly universal.